Okay, 9.2, graphing simple rational functions. Now, in the past, we know that a linear parent function looks like that. And we know that a quadratic parent function looks like that. And a cubic function looks like that. Today we're going to talk about rational functions, and a rational function is just a fraction. Okay? This right here is the simplest rational function you can write. Before we add parameters to it, that's the easiest one we can write. So that is the rational parent function. So what I want you to do is go to your calculator and type in your y equals 1 over x. 1 divided by x and y equals. And then hit graph. Now, notice what this graph looks like. It is not one continual graph like before. Okay, so a linear went like this and it was just one continual graph. Quadratic was a U shape. It was one continual graph. Cubic went like this and it was one continual graph. This is not. This is going to go here and here. And when we start adding parameters to it, it's going to move from that situation. Notice that this is close to 0 here. It never touches. It also goes close to the y-axis here and never touches. Same thing here. Close to the y-axis, never touches. Close to the x-axis, never touches. This y-axis is called a vertical asymptote. Okay? It's a line drawn to where the graph gets really, really close to it, but it doesn't touch it. This axis here, the x-axis, is a horizontal asymptote. The graph gets really, really close to it, but it never touches it. Yes, sir.
How do you spell asymptote?
A-S-Y-M-P-T-O-T-E. You're welcome.
And that's when it like gets right next to it, doesn't touch
Never touches. All right, continuing there in the middle of page 469. It says state the domain. So the domain here is going to be a little bit different because we actually have two parts of a graph and it's not continual. If you remember, domain is left and right. So how far left does our graph go and how far right does our graph go? Our domain covers everything except what? 0. All right? So first thing we're going to write it as an inequality. So you would write x is less than 0 or x is greater than 0. Doesn't that cover everything except 0? So fill in right there. X is less than 0. X is greater than 0. Remember, when we're talking domain, we're talking about x, left and right. So if we wrote it in set notation, little bracket, braces, whatever you want to call it, x, such that x is not equal to 0. So x is everything except 0. Now in interval notation. Now here's a symbol that you probably haven't had, maybe back in middle school. A U. Have you ever seen the U? It means union. It means both situations. So you would write this as parentheses, negative infinity to 0, and I have another set of parentheses. Now, why did I put a 0 there and parentheses? It doesn't touch. So parentheses means it doesn't touch. So from negative infinity to 0 and doesn't touch, union 0 to positive infinity. So actually, when I put zeros there, what is that really saying? Everything except 0. Okay? That means everything except 0. 0 is not included because there are parentheses there. Questions? Same rules as we've had before. All right? Now look at the bottom of page 469. Now, this may be something you haven't seen before. And you're going to have to look at sorry. Sorry. You're going to have to look at this because we have two different parts of the graph. So at the bottom of page 469, it says, as this one you've seen, I'm sorry. This one you have, this one you haven't. As x approaches positive infinity, as x approaches positive infinity, y approaches 0. So it's getting smaller and smaller and smaller here, probably fractions and decimals and so forth. Okay, so that's a 0. As x approaches negative infinity, what is f of x approaching? 0 again. Getting smaller and smaller and smaller. Now, here's something we haven't done before, but it's really easy. As x approaches 0 from the positive direction. See that little plus right there? It's in the middle of page 4. Look, the very next page. What page is that? 470. The middle of page 470. As x approaches 0 from the positive side. So as my graph moves towards 0 from the positive side, what does my y do? Approach what? Positive infinity. That's all it's saying is x approaches 0 from the positive side, f of x approaches positive infinity. All right, next one. As x approaches 0 from the negative side, as we move this way on the graph, as x approaches 0 from the negative side, what does f of x do? Approaches negative infinity. Any questions?